Imagine Earth spinning like normal. Clouds move, oceans turn, and the ground under you quietly carries you east. Now press one impossible button. The planet stops rotating instantly, but the air, oceans, and you do not. Near the equator, that means everything loose keeps moving east at roughly 1,000 miles per hour. The first disaster is not space, it is inertia. The ground stops while almost everything above it keeps going. Then the oceans surge, then the atmosphere reorganizes, then the meaning of day and night breaks. So today, we are asking what survives when Earth keeps its gravity, but loses its spin. First, a rule for the thought experiment. We are not explaining how Earth stops, because that part is already impossible. A collision powerful enough to cancel Earth's rotation would be its own planet-ending story. So we freeze the solid Earth by magic, then follow the physics of everything that was already moving. That one rule makes the first few minutes brutally simple. Moving things keep moving unless something stops them. At the equator, you are already traveling around Earth at about 465 meters per second. You do not feel that now because the ground, the air, the buildings, and your body move together. But if the ground suddenly stops, your body still has that sideways speed for a moment. Buildings anchored to the crust stop with the crust, while loose objects try to continue east. That difference is where the damage comes from, not because gravity fails, but because motion suddenly disagrees. The atmosphere would keep racing east too, turning normal air into planet-scale destructive wind. The oceans would also keep moving because water has momentum just like a person or a car. So the first picture is not people floating upward. It is air, water, and debris moving sideways. But the disaster is not equal everywhere. Earth's rotation speed depends on latitude. At the equator, you make the biggest circle each day, so your sideways speed is highest. Halfway toward the pole, the circle is smaller, so the speed is lower. At the poles, you mostly spin in place instead of racing around a giant circle. That means equatorial regions get the worst instant sideways hit, while polar regions avoid that part. Avoiding the first sideways blast does not make the poles comfortable, it just changes the kind of problem. Now for the big myth. If Earth stops spinning, do we all fly into space? No. Rotation gives a tiny outward effect, but gravity is much stronger. Earth's escape velocity is about 11.2 kilometers per second. The equator's rotation speed is less than half a kilometer per second, so stopping the spin would not cancel gravity. It would actually make you weigh slightly more at the equator. That detail matters because the disaster is not escaping Earth. It is surviving Earth's surface. The atmosphere is next because it does not politely stop just because the ground does. Near the equator, air keeps moving east at extreme speed relative to the stopped surface. Mountains, continents, forests, and cities become obstacles in a global wind tunnel. Dust, water spray, and debris would be picked up, turning the lower atmosphere into a grinding mess. As the chaos spreads, the old weather map stops making sense. The Coriolis effect, the rotating planet twist that curves winds and currents, would vanish. That does not mean weather becomes calm. It means the entire circulation pattern has to rebuild. Modern hurricane patterns would not keep working the same way because their spin depends on Earth's rotation. Now the oceans arrive, and this is where the map starts to look impossible. The first ocean problem is momentum. Water keeps sliding east over a surface that just stopped. That means enormous surges against coastlines, islands, and anything low enough to meet moving water. But the long-term ocean problem is stranger than one giant wave. Right now, Earth's rotation helps make the planet slightly wider at the equator. The ocean follows that shape, piling more water around the equatorial bulge than a perfect sphere would. If rotation disappears, that bulge no longer has the same support. Over time, sea level would redistribute, with water tending away from the equator and toward higher latitudes. Some equatorial seafloor could become land, while other regions drown under new polar oceans. So the coastline map is not just damaged, it is rewritten. Suppose somehow the first violence ends, the next enemy is time. Earth would still orbit the sun. It would not simply park one side in permanent daylight. But without normal rotation, the solar day becomes roughly a year long. One region can face months of sunlight, heating far beyond a normal summer. Later, that same region can face months of darkness, losing heat for far too long. The atmosphere would try to move heat around, but the pattern would be nothing like today's climate. Instead of normal daily warming and cooling, Earth gets a slow bake and freeze cycle. Life that depends on normal seasons, winds and rainfall would be under extreme stress. Now zoom out to the new Earth, long after the instant chaos. The equator loses the old speed advantage, the air loses Coriolis steering, and the oceans seek a new level. That creates a planet with new coastlines, new wind belts, and brutal sunlight schedules. The safest areas, if any exist, would likely be special cases, not cozy new vacation spots. Underground spaces, polar geometry, and carefully controlled habitats would matter more than beaches or cities. But this is not a survival guide. It is a map of why rotation quietly supports normal life. One more claim needs a careful answer. Would Earth's magnetic field instantly shut off? Not instantly, and not because the surface spin alone acts like a toy motor. The field comes from moving electrically conducting material deep in Earth's outer core. Rotation helps organize that motion, so a stopped Earth could change the dynamo over time. But surface stops, magnetic shield instantly vanishes is too simple. Also, Earth is not secretly about to stop tomorrow. Real tidal friction changes the length of the day by tiny amounts over long times. That is not cinematic braking. It is slow planetary bookkeeping. The sudden stop story works because it reveals what rotation normally hides. So here's the clean timeline. First, inertia turns the surface into a sideways disaster. Second, the atmosphere and oceans keep moving, creating global wind and surge problems. Third, gravity still wins, so the danger is not flying away into space. Fourth, the old weather engine breaks because Coriolis disappears. Fifth, the oceans and coastlines slowly rearrange as the equatorial bulge relaxes. Sixth, the day-night cycle becomes a year-scale heating and freezing problem. The final answer is simple and awful. Earth would remain a planet, but not a recognizable home. Rotation is not just background motion, it is part of the machinery that makes Earth feel normal. Take away that spin, and the planet becomes a physics lesson written in wind, water, heat, and time. So here is the brain nest question. Which consequence surprised you most? Was it the sideways speed, the ocean shift, the year-long day, or the fact that gravity still wins? Drop your answer in the comments and subscribe to Brain Nest for more science explained with simple drawings.